Hi guys, this is Miss Rainey, your trusty environmental systems teacher, coming to you today from C347 at MacArthur High School to talk about Earth and meteorology. So the first thing we're going to look at is the structure and science of the atmosphere. Take a few minutes to pause the video, and I can't make this the right size, but try and pause the video and take a few moments to copy down this graphic. What you're looking at here is altitude on the y-axis, whether it's in kilometers or miles. It's fine either way. And you don't need to correlate this directly to kilometers or miles on your picture necessarily. What I'm interested in is that you get the general trend line. So notice that the trend for atmospheric pressure, that's what's on the black trend line. Notice that the trend for atmospheric pressure is really steep until you start getting close to sea level, and then you can tell that the closer you are to the Earth, the more pressure there is. Alright, so if you look at the other side on the x-axis, you can see temperature. And temperature doesn't correlate directly with the closer you are to the Earth's surface. It's really weird. You get up to the ozone layer and you see a difference in the trend, and in fact that's how the layers are defined. And so you get close to the Earth's surface, you get what you're used to. The higher you go, the colder it gets. Look at the trend in temperature down here. You go a little bit higher past the ozone layer into the stratosphere, and now it starts getting warmer as you go up. You get to the stratopause, that's the boundary between the stratosphere and the mesosphere. And again, it starts getting colder, and then you get these wild fluctuations because you don't have the protection of the Earth's atmosphere anymore. So it can get really hot or really cold way up here. That's why it's called the thermosphere. So here's what you do need. You need the trends. You need the names of the layers for sure. And you need the names of the boundaries in between the layers. Okay? We don't necessarily need to memorize what numbers, okay, at least not for this level. And we don't need to necessarily memorize these numbers either on the y-axis. At what altitude in kilometers and miles does this happen? I want you to know order, and I want you to know boundaries, and I want you to know trends. Okay. Here's a little bit of information about the troposphere. It's mostly nitrogen. That's what you're breathing in. We get a little bit of oxygen, a lot of water vapor, and some carbon dioxide. If there's ozone in the troposphere, it's kind of in the quote-unquote wrong place. It starts doing a little bit of damage. The next layer is the stratosphere, and the ozone layer is the boundary between us and the stratosphere. So that ozone gas is what stops a bunch of the UV radiation from getting us. The troposphere is the furthest down, and so it's under the most pressure. It's got the most mass. It's also mostly nitrogen. This is where the weather happens, and this is where the higher you go, the colder it gets. All right. Stratosphere is generally pretty calm. You can get some big trends in some of those higher winds and clouds. The remarkable thing about the stratosphere is that ozone layer. So that's really what protects you from UV radiation, and that's what I want you to associate the most with the stratosphere. The mesosphere is exactly what it sounds like. It's kind of in the middle. Here, the higher you go, again, the colder it gets. And in the thermosphere, you have really crazily fluctuating temperatures. So when the sun is out, it can get really hot. When the sun is down, it can get really cold. There's not much of anything to protect you, to insulate you from what the sun is doing. I don't know why that's in there twice. All right, the ocean currents, because water has a very high heat capacity, it can carry lots and lots of energy. Also, because the ocean's color tends to be a darker blue as opposed to the white ice caps and the the different color of the continents, it tends to absorb more heat than anything else. Because of that, ocean currents carry huge amounts of energy, and they can really move that energy from one part of the earth to the other, really change a lot of climate. So how does that energy move from one part to the other? Well, it can happen through direct contact. That's basically conduction. And again, feel free to pause the video and write down, whatever you haven't had enough time to write down. Convection is moving heat through fluids. So a fluid can be an ocean current, it can be any other kind of water, it can also be air and wind. So if the heat is transferred that way, we consider that a convection. Radiation is the only way that the heat can get to us from the sun. It doesn't have to travel through a medium. Radiation is what drives the weather, and so that disparity between the really, really high concentrated radiation that gets to the equator versus the lower concentration of radiation that gets to the poles is what gives us that big difference in weather at each of those places. Scattering is what makes the sky blue. The sun hits the earth at different angles, and at different times of the day you see different colors. It's most obvious during the sunrise and sunset. Albedo is that effect that the white colors on the earth have. So the glaciers, the ice sheets, they can reflect a lot of that heat back. On the other hand, black asphalt, dark blue ocean absorbs a lot of that heat. So that radiation, that heat energy that's absorbed, that's what runs the water cycle. The water cycle is what drives the winds. That's what drives the ocean currents. It powers photosynthesis from the same source of energy. The solar radiation controls the temperature all around the earth. So if there isn't a lot of moisture in the atmosphere, then you're going to have a big, big temperature differential because you don't have that blanket to insulate you. The 25-degree incline of the earth also has a big influence on the concentration of sunlight that hits you at different times. It's why we have those 4 seasons. So that combined with global air circulation, you combine that with the global water currents, and you end up getting different weather in different places. All right, so if you have any questions, make sure you bring them tomorrow. Be ready for a quiz in a couple of days over general trends of weather on the earth. Thanks very much, guys.